I'm getting less and less in the mood to do 4,000 horsepower and engine dyno stuff. It's hard on my brain. 1972 Monte Carlo drag radial with SMX power. All right, first things first, Sugar Mama giveaway. We have, actually I haven't done anything. The sweepstakes company has selected a winner. I have not talked to him yet. So coming up here, I gotta talk with him. I gotta make sure everything's all cool. Apparently he says, told the sweepstakes company he wants to take it, but I need to talk to them first. Gonna announce that, I think probably Monday who it is. Like I said, I haven't called, talked to anybody yet. So that is coming up. Then, just real quickly, engines that are in process. This is James Kolish's Pro Charge right here, SMX, coming up pretty shortly. James has been extremely patient because I've been extremely far behind on this. Thank you so much, James. Another SMX for customer over in England. Another one that I'm waiting for some parts to finish up. Parts that I don't make yet. And so that one is going SML, small block Chevy, big block Ford. Really nice piece here for John Gardner and Matt Exner. Gonna be a really good deal. Now, back to the video. Hey everybody, so you remember the dyno blew up and we just started showing some modifications to fit the new billet absorber from yourdyno.com. And so some good guys, Dave Currents and Al Thomas, came to help out. Really appreciate the help that they did of rebuilding this and getting the absorber remounted, set up to work properly. So really appreciate them doing that. And there is the your dyno billet absorber. So really excited to start working on and testing through this thing and give you some bunch more tech and a bunch more stuff on the absorber as we go through this video. So once again, I want to thank these guys that came and helped out. Couldn't get this stuff done without them. Very thankful. Alrighty, so you remember the dyno explosion. It blew that blower up.
Yeah, it did.
Holy cow. We have now gotten the dyno all the way to the point where we're putting the engine in right now and gonna hook this up. But Jostein from Your Dyno, he is Your Dyno. Your Dyno, yes, it's Your Dyno guy. He's my dyno guy, but we call it Your Dyno, even though it really is my dyno guy. But anyways, so we have everything installed here. So you saw that we've been working on this just a little, we had to modify stuff because we put on the new billet absorber from Your Dyno. So we have everything plumbed now. We had to move stuff because it's on a different center line than what a Stutzka absorber is. So we had to change stuff right there. But I like the way it drives, and it already has splined shafts. So and you can flip this around. Yep. You can run it either direction. So this is does that mean it is a toroidal design or not? Yep. It is a toroidal design. Yeah, that's right. So a toroidal design will run in either rotation. Yeah. What's the one that's not toroidal, so it's directional? What do they call that?
And I forgot I forgot the name of that. But
I forgot the name of it too.
Yeah.
Doesn't matter because we don't have one.
The toroidal is the best one.
Toroidal is the best one. Yeah. Okay, so the old Stutzka stuff. Show you a couple little clips here, couple little pictures. But the old Stutzka stuff is straight vane. It works. It's not as efficient. Now, what we're trying to do here too is because Yolstein does all of the control valve and all the data acquisition, so we're trying to get, ultimately, we're going to have both dynos be exactly the same with billet absorbers, Yolstein's controls, and data acquisition. Currently, the other dyno over there still has a D-pack and Stutzka. This one's been your dyno for a while, but the billet absorber is brand new since we broke the dyno off of here when that blower exploded. So there was no sense fixing it and repairing it because I had this thing sitting on the shelf waiting for, well, Yolstein's been waiting for me for a couple months now. So I've had this thing, so now we're all mounted up. I'm happy with all the hardware and the finish of stuff. Happy with that, really happy with the spline. If we were ever going to, this makes a very easy coupling to put another absorber back here.
That's right.
So you could stack absorbers. That is not currently possible with, I don't think with anybody's. Maybe Land and Sea stuff had some stackable ones, but they're out of business, so there's no more of them. So this has really nice stuff, including, how many tooth wheel is that for?
30.
So 30 tooth wheel. It is stackable absorbers. Honestly, I'm probably not gonna do. We're gonna see how much load these take. I think everything's gonna be good because I'm getting less and less in the mood to do 4,000 horsepower and engine dyno stuff because it is so hard on parts. It's hard on my brain too. But so we're getting very close. Now there's interesting things about your dyno system because you try to use a lot of what would you call it, like open source kind of stuff?
Yeah.
Is that the correct terminology?
Yeah, you can call it off-the-shelf parts.
Off-the-shelf parts that you can get. You can do like all the control work here. So this is just a common power supply, right?
Right.
Common power supply you buy anywhere. A lot of common componentry. This is yours though.
Yeah.
This you're building. Valves. This is like a common valve, isn't it?
It's made specifically for us.
Oh, it is made specifically for you.
It's
Okay.
made for us. You see.
Okay. Oh, it does go. Will it spin all the way around, or it always spins?
It's like a carburetor, right? So it opens, and this is full throttle, so to speak, right? So that's fully open, then that's when you have full brake, and then when you close it, then there is no water flowing, right? So the brake doesn't have any water.
Yep, and there's a Teflon seal that's in the middle
Yep.
to seal it all off. This is a inch and a half?
Yeah, this is engine oil.
Inch and a half.
So this one here is 2.
Yep, okay. Got it.
But you can buy off-the-shelf sensors. I think that's the most important part.
Yeah, off-the-shelf sensors. So you can buy a lot of things that you don't have to just specifically get from your dyno. You can easily get it anywhere.
Yeah.
Now the dyno control, so this is a, what's in here?
It's a butterfly.
Butterfly valve, yeah.
2-inch.
Yep, this one is a 2-inch butterfly valve, and so we've already been running this. We've already been running on the Stutzka absorber. So I'm really kind of excited to see if we can get quicker response because of the absorber, right?
Yeah.
And because it was a little latent on my Stutzka, and it could be a little bit of lines and height. There's a lot of crap that goes along with it. But I think we're really nice tight. You think it's all correct?
Absolutely. It's ready to go.
Okay, so we're ready to go. So we've been cleaning up a couple little things and getting some stuff taken care of, but we're gonna put my Dyno Mule on here and we'll show you that whole thing. So my Dyno Mule is an engine that's been, mine's been in the shop for, shucks, it's been in the shop for over 10 years. So it's 540 cubic inch, big block Chevrolet. This thing makes the same horsepower every single time. Regardless, it only makes 740. It makes 740, 740, 740. I mean, plus or minus 1 or 2, but I mean, every single time. It never changes. It's awesome. Good old bracket carbureted engine. It's just bulletproof. So anyways, we're gonna hook that thing up. We still are using I'm sorry. So this is spline input here too, and then that allows me to still use my 10 spline, 1.5" diameter spline shaft right there. And we'll have to watch my stack up heights here. We might have to shorten this shaft. That doesn't go in as far as I remember. Oh, no, it's just got something sticking in it. There we go. And then has a spline drive plate on the engine right here. So no U-joints. Big horsepower stuff, U-joints is really problematic on engine dyno stuff. Engine dynos break that stuff all the time because they get really abused. It's something terrible. Just like starters and flywheels get kicked off of these things all the time. So anyways, this is going to hook up really nice. Spline drive, no parts to blow up like that, so I'm happy about that. And but I'm pretty excited to see what this new absorber is going to do. So we're going to be testing this thing maybe today. I think we'll probably get everything all up and done today. So stay tuned. Alrighty, today we are working on Alan Whitaker's. What year Monte Carlo? What year Monte Carlo is this, Alan?
1972.
1972 Monte Carlo drag radial with SMX powered. Twin turbo, methanol, dual fuel, drag and drive. This is like steel. Super cool, super pretty car here, as you can see. And stock interior. And you had this car from when it was brand new, didn't you?
No.
No.
I was 17. I've had it 38 years. It was my first car.
Your first car?
My first car.
Yeah, all right. Well, I know you're like 70 something.
Yeah, I'm the same age as you.
Yeah.
We're old.
Old. Now he's already, Alan's already, if you've been keeping track, Alan's already been running some drag and drive events with this. Usually it's always traction limited has continuously been the problem. Gonna be working on that, but we freshened up the engine and wanted to make sure everything was all cool. So we've never hub dynoed this car, and in fact we've never engine dynoed this. We never engine dynoed it either.
No.
Oh, we've never done anything with this. So yeah, so now it's here on the hub dyno.
Yeah.
And you can see here, this is a. Oh, you got to pull the pin, to get the hood to go down. Ah, I see. I'll have Alan close the hood here. You can close the hood for a second. Show everybody that. And these are the twin 88s on this?
94s.
94s. 94s. Yeah. Sweet.
Just an old street car.
Just your average street car. Alrighty. Let's make a pull. Nice, easy. 3,000. Where'd it go? 3,000, and there you go. 8 horsepower. I did rev it up just a little bit higher there than I should have. I'll look at the data log here and we'll see what kind of mile an hour this was actually at. Dang it. There we go. Speed. Yeah, it probably was 220, yeah. What? Converter's tight. Something else. All right. And come over here, look at data. Oh, I did. It got right away from me there, right at the very end. And just tickled the rev limiter up there at 89. 9,000, yeah, just touched the rev limiter up there. Don't normally do that. Boost level was 37 pounds of boost right there. It did come up here and hit a grand total of 39 pounds of boost lower in the pole. And then I didn't have enough dome pressure on it out here to maintain that, and then tickled that rev limiter. So I think everything's looking pretty darn sweet. Yeah, no, that's pretty good. Let's go look at our EGTs. Oh, no, god darn it. Got a little wiggler here. Which one is that? Number one. Number one's got a little wiggly there, so it dropped out. Now that might be a little bit of noise because it still maintains and it makes these really super dramatic changes. That's more like noise issue right there. But all things said and done, not a big deal. EGTs are cool, look nice. We'll do some spark plug reads. I think everything looks great. Like I said up here, that was on happiness up very close on the rev limiter right there. It should be on rev limiter period. Let's see where the rev limiter set at here. Get rid of that and go here, 10,000. All right, so it's got is unhappy up there. This needs to be changed. Not sure why that was that way. I did not set that rev limiter, Devin. Yep, and yep. All right. So it was unhappy way up high. That is interesting right there, yeah. So it was not on a rev limiter. It's supposed to have been on a rev limiter right there. So it is got a little unhappy spot right there for sure. Probably picking up, it might be picking up noise, might be picking up, I'm not sure. I think we're gonna have to take a look at that. But the thing is pretty darn sweet. I think everything is really good on this thing. This is a really super nice, super cool car. Hood down, 3,000 horsepower. Can't beat that. Billy bad boy. Alrighty, everything is hooked up. This is my test mule, 540 cubic inch, old school. Shoot, nearly 20 years old. Now we've freshened it up since then, but nearly 20-year-old 540. Old school technology. That's why it doesn't make as much horsepower. But we got everything hooked up. We're all set here. So we're going to have to do calibration testing to basically get our start positions and start load positions and rates for this type of absorber versus the other one, the old Stutska they had. So we're all hooked up here. We got our sensors all hooked up, put in our fuel flow turbines, which I haven't used in a long time. So we're gonna try verifying all that. You can see here, this whole valving system really is nice. I really do like it. Quite nice. And then the way it plumbs into the billet absorber, speed sensor. Really happy with the hard parts. Everything is like good. Real happy with that. I do have a uh, uh, shaft guard that goes over here. I just don't have it on right this second. And I think we're ready to rock and roll. Is it collecting and averaging one data point, or?
No, so that's gonna, let me show you. So in RPM now it's gonna look a bit like that. So it's better to look at it in time. So here you could see.
So when it flashed up the big number on, or the number on the screen,
Yeah.
where did it come up with that number, or is that just the last number it collected?
No, that's the that's the maximum that it got during that. Yeah.
Okay.
So let me show. Let's put the RPM here. No.
So what we're doing here is setting the PID controls so that the valve is controlling without oscillating.
If it's a bit faster, then it may need a few iterations here.
Yep. Okay.
Sweeps are easier to get to go nice. Steady state is harder to make it perfect.
Okay. Steady state's harder. Sweeping is easier, which is interesting. All right. I'm also going to raise this up to 4,000 RPM. So we just hit the arrow up. You can see it was changing right down there. So that's our steady state. And then after we get that set up, we'll do a sweep test here. And we need to also save this file under, let's save this file under test mule.
Yep. Yeah, we also see the target out there.
Ah, there you go.
Yeah, we should call it something different than that, right? Let me change to a new session.
Yep. So what's going on here is we're looking at what the valve is actually doing, because he's able to record the valve positions and what it's calling for, what it's trying to do, what it actually did do. So we're going through all this information, and we go in and just happen to put our hand on the absorber and noticed it was very hot. And it's like, whoa, wait a minute, that is not exactly right. It was controlling perfectly, everything worked great. We did another sweep test and it was controlled perfectly, but we went in, touched the absorber, and it was very hot. So what you're gonna see here next is us actually doing some testing on outputs and the exhaust of the dyno, or the water outlet of the dyno. Now, we're getting ready to do a test on this where we have disconnected the outlets from the normal drain and I'm actually spraying into these buckets so we can measure how much water came out and basically how hot it was. Now you can hear it made a really nice sweep, and you could just see a little bit of steam coming out of that the green tote there. So we're exhausting all of it. It'll be interesting. So here we're actually gonna spray the water because it didn't use much water. We're actually gonna watch the water exiting the dyno. So this is how much the dyno is actually using live. Never even seen this before. Now when the water goes in, this is well water, so it's roughly 52, 55 degrees, and it comes out a little hot. This is not out of the engine either. This is just out of the absorber. Alrighty, so what we're doing is we've got both dynos converted over to the Your Dyno software. You see that up on the screen. We're gonna get a second monitor so we can watch it, all the gauges, and watch it data log and graph at live in correlation to what it just was, so which is pretty cool. So what we're doing here is we're finding out if what's going on with the absorber, because we think maybe it's operating perfectly. In fact, it is sweeping really, really nice, but our outlet temperature is really high, and we're trying to figure out what's going on. If it's correlated to this size engine, and if we like put in a 2,000 horsepower engine, it takes more water, which would cool it. So we're figuring out a little bit of physics, math, whatever. We're proving something out, trying to prove it. So we've changed routing on our outlet lines to here. This is kind of temporary for now because we got this fitting in here to measure temperature. And then something else kind of neat over the other side is instead of just, see, you always have to vent. You're blowing water in, or you pressurize water in, and then it circulates the water. It's actually shearing the water. I got a little video on this. So it's shearing the water, makes a lot of heat, and then it spits the water out. That's what creates the load is in there, okay? So more pressure, more volume, more load, like a torque converter in a car. It's the exact same thing, actually. Yeah, it's exactly the same thing. So one of the things you always have to do is you have to have it vented. And so instead of it venting, we're actually putting pressurized air into the vent, which should blow the water out the exhaust, and it doesn't care about the inlet water because the inlet water is at 60 psi, so it doesn't care about that. It overcomes that. I don't think that matters at all. I wouldn't matter at all.
No, the point is to get more water through the brake.
Yeah,
so we want to help the exit or the exhaust
yeah.
on the one.
Yeah, this should help exit water out the exhaust of the brake, not the engine, the exhaust of the brake. So we're just kind of trying to prove some stuff out here and figure out exactly what's going on. But it's curious because we didn't think there was anything going on until you came in and actually touched it, because it was operating great and operating perfect. And it's not out of limits, it's just not what we expected. So they want to make sure, Yostein wants to make sure it's correct and perfect. So that's what we're doing. We're trying to figure out what needs to happen to make it perfect, or at least within parameters of what we believe perfect is.
Yeah, and if needed, we'll make a bigger outlet so we get more water out of the brake.
Yeah, if needed, yeah. So we're gonna sit there, since this is just the old mule, and it's right dead on the money like it always is. So we're going to do a long steady state pull on it longer than what we normally would, because what we want to do is we're just trying to see does the water temperature continue to climb, which would be a problem, or does it climb and then plateau, which is what is expected, right? Okay.
So we are at 5,000 now. Steady state.
Ran out of fuel. That's interesting because it was
Good.
I just pulled back because it just stayed steady. It was
Nothing
just
happened.
yeah, nothing happened. So it's definitely RPM related.
Exactly. It's only up in the 6,000-7,000 it happens. But that's also when the valve closes. Or we can do a slow sweep, a very slow sweep.
Yeah, we can do a very slow sleep.
Because this was temperature-wise was super cool actually. Right?
Yeah.
It's up to 130 and it actually dropped a little bit. Well, that was good.
Yeah. Well, while it was running, I always saw it at 130.
Yeah. Yeah, that's right. That's here.
Yeah.
That's here. That's 130. But it kind of leveled off for sure here, huh?
Yeah.
Yeah.
Yeah. Just
And then as
plateaued.
you roll down, of course, it dropped. Yeah.
All right. Well, we can do a
Let's do a slow sweep.
slow sweep
Yeah.
again and. Now, what you see is funny here is the exhaust got so hot all the way through the room that it's burning off any residual oil or stuff that's burned off in the pipe before. You can do stuff like that on an engine like this, on other. You can't do that on other kind of engines. They're just not. Well, it's a horsepower deal. You just a 4,000 horsepower engine does not tolerate that.
The sweep was nice though.
The sweep? Well, yeah. I was worried. It was so slow. I'm thinking,
But we had too high temperature.
and it's exactly the same horsepower.
Yeah.
Exactly. Sweeping. Yeah. So the moment inertia must be
Perfect.
dead on because it's exactly the same horsepower as when we sweep it at 900 RPM. But you can see it's terrible smoking in there. It was hot.
Yeah. Too hot.
But the water temp, I saw 193 when it pulled out.
Yeah. Exactly. So we need to do something on that exhaust of the brake.
Yeah, so there's something going on there.
Yeah.
With the and you saw us. We did the spraying out with two short little hoses this big, just spraying into a bucket. So there's no restriction, and still does it. So there's probably just a little upgrade or something going on, and it very well still can be related to. It's really hard to figure and comprehend, but if the bigger engines require more water, so we don't really know yet if the bigger engines would fix it, but it's still a problem here because if we see, and you can explain this better, but if we see 190 degree water temperature outlet, internally inside, very similar to the torque converter deal, the wagon, when it turns stainless steel blue gold color, but the oil temperature was only outlet temperature was 4. I had it at 600, but it was like 450, and it still turned stainless blue.
Yeah.
So internally, we know that it's boiling. Basically, it boils internally and would cavitate, doesn't it?
Yeah, so I don't think it happened now because then the regulation would
unload.
be good. So we're still semi on the safe, on the right side, but
Right.
definitely approaching the bad side.
So if the water gets too hot internally in the absorber, it I think it does two things. Doesn't it? The first thing, it steams and it would just unload.
Yeah.
It just boils and turns the vapor and unloads the engine,
Yeah.
which is bad, and you'd notice that right away.
Yeah.
And then it does something with like at the tips where it boils off, it like erodes or does something to
Yeah.
the rotors and stuff. Doesn't
Yeah, it's not good for the brake at all. Yeah, also for the seals. So we should definitely stay below boiling point for sure.
it? Yeah.
Far from it. So
It does something. What do they?
Cavitation.
Yeah, the cavitation does something to the
yeah, it fits.
electrolysis, or
yeah.
it does something weird
Yeah,
to the actual metal.
yeah. Right.
Okay.
Wears it out very quickly.
Yeah, yeah. You should see my old ones.
Yeah.
The one that we blew up out of here actually had an external pinhole because it had eaten all the way through the aluminum casing over the years, and just from normal. And that one, it doesn't even get hot. It just there's a problem with I don't know, that something happens at the tips, and whether it's the rotor and or the tip of the stator.
Okay.
Is it the stator? Yeah, rotor, stator.
Yeah, rotor,
The stator, and it would actually wear away at the stator. It kept on wearing away, and it actually ended up having a little pinhole in it. So that's the other reason I had to get rid of it. So, anyways, I mean, it sweeps, it controls, it does everything perfect. I think we just need to figure out a little upgrade, and
A little bit bigger exhaust is my
yes,
tip.
a little bit bigger the exhaust, and they'll get that figured out. So it's all going to be good because we're going to be converting that dyno over to the billet absorber also. Obviously, as soon as we get this one all figured out and sorted out, and it'll be awesome. So,
Very good.
all right, excellent. So we'll clear out the smoky room, and I think we're done testing, and Jostein's got to go back to Norway.
That's right.
So, all right, I appreciate it, my friend.
Very good.
Thank you much,
Here.
and
Thank
looking
you.
forward to it. And really like the way everything's working out and working. That's not a big deal. Making things right. That's what matters. So
That's right.
yep.
All right.
All right. I'm Steve Morris. Have a great day.